Assalamualaikum. Today our group will present our task which is spatial analysis. This task is presented by Haziq, Izzah and Amel. The objectives of our task is vector analysis, raster analysis, point and polygon, line in area and area on area. Vector analysis, which is refers to the manipulation and analysis of spatial data represented using vector data models. GIS is a technology that deals with the capture, storage, analysis and visualization of spatial and geographic data. Vector analysis in GIS involves the application of mathematical and geometric operations to vector-based spatial data. The key components of vector analysis, which is vector data model, vector operations, topological relationships, geoprocessing tools, and cartographic model. Vector data model. It uses points, lines, and polygons to represent geographic features. It also specially deals with operations performed on vector data. Vector operations. Overlay analysis. Overlaying multiple layers of vector data to analyze spatial relationships and derive new information. Its common overlay operations include union, intersection, difference, and identity. And then buffering. It will create a zone around a feature, usually measured in distance units, to analyze proximity and spatial relationships. Lastly, network analysis. It analyzes networks such as road networks or utility networks to find the shortest path, determine connectivity, or optimize routes. For topological relationships, it often involves understanding and utilizing topological relationships, which describe the spatial connectivity and adjacency of geographic features. For example, including connectivity, containment, and adjacency. For geoprocessing tools, it provides a variety of geoprocessing tools for vector analysis. These tools to automate spatial operations and allow users to perform complex analysis on geographic datasets. For cartographic modeling, it uses vector analysis to create and manipulate geographic models for cartographic representation. This involves symbolizing and visualizing spatial data in our maps. On the other hand, we also have raster analysis. Raster analysis involves the processing and analysis of spatial data, which is represented using a raster data model. In contrast to vector data models as we speak just now, it represents geographic features as points, lines, and polygons. Raster data models present spatial information. Each cell in a raster dataset contains a value, and the arrangement of cells forms a regular grid. The key component in raster analysis, which is raster data model, raster operations, terrain analysis, image processing, and raster query and retrieval. For raster data model, in raster datasets, the geographic space is divided into a regular grid of cells. Each cell contains a value that represents a specific attribute or characteristic, such as elevation, temperature, land cover type, or population density. For raster operations, it involves map algebra. It performs mathematical operations on raster datasets such as addition, subtraction, multiplication, and division. For overlay analysis, overlaying multiple raster layers to analyze the spatial relationships and interactions between different phenomena. These include operations like overlay, intersection, union, and buffering in the context of raster dataset. For zonal statistics, it will calculate summary statistics such as mean, sum, maximum, or minimum. Lastly, distance analysis. It will calculate distances from specific locations or features in a raster dataset, which is useful for applications such as proximity analysis. Terrain analysis. It will analyze raster evaluation models to derive information about the terrain such as slope, aspect, and hill shape. This is commonly used in applications like hydrology, landform, classification, and viewshed analysis. For image processing, raster analysis is crucial for processing and analyzing satellite imagery and aerial photographs. This includes such as image classification, change detection, and image enhancement. Lastly, for raster analysis is raster query and retrieval. This is, it will extract information from raster datasets based on spatial and attribute criteria. This involves querying and retrieving data from specific locations or areas within a raster dataset.
A point is a location that can be specified by coordinates such as longitude and latitude. A polygon is a closed shape that can be defined by a set of vertices and edges. Point in polygon is a spatial analysis technique that involves checking whether a given point is located within a polygon or not. There are different ways to perform point in polygon analysis, depending on the complexity of the polygons and the numbers of points. One of the common methods is to use ray casting, which stimulates rays from the point to the polygon and count how many of them intersect with the polygon boundaries. As you can see on the right, this is the example scenario of ray casting.
In the context of spatial analysis in GIS, line in area could refer to a spatial relationships or analysis involving lines and areas. This typically involves examining the interactions or relationships between linear features and the areas they intersect, touch, or overlap. In spatial analysis within GIS, the concept of area on area typically refers to the analysis of the spatial distribution or relationship between two or more geographic areas. This can involve analyzing the overlap, adjacency, or other spatial relationships between different polygons or areas on a map.
Spatial analysis is regarded to be the visualization tool for solving the wide range of issues, closely linked with social and ecological factors in inhabited areas, or areas intended for further settlement. So that's all from us. We hope that this video will help you understand more about spatial analysis, and thank you for watching.